now that we're a little prepared, now that we've heard the songs a little bit, let's start in on some of these problems. So first, let's start with the sine of 75. We want to find the sine of 75 degrees. And again, you could substitute other angles. I'm just picking 75 because, well, it's simple and it's a pretty good example to kind of get you started with this idea. So first, what we need to do is we need to figure out which identity we're going to use and then start looking at it. So right here, I've got the sine of some angle plus another angle. So I automatically know, since it's sine, that I need to use the sine shuffle. So I can start by kind of filling in the individual pieces. So sine of an angle plus an angle is sine shuffle. It's sine, cosine, cosine, sine. So once again, that's sine, cosine, cosine, sine. And now once I've got kind of that skeleton in there, I can actually use my two angles. So it'll be 30 in the first spot, and then in the second spot it'll be our second angle, which is 45 degrees. And so this expression right here, with the green and the red, right there, is going to be equal to the sine of 30 plus 45, which is the same thing as the sine of 75. So if we can find this value, like this entire thing, we'll actually have the sine of 75 degrees, as weird as that sounds. So now, before we do it, I might say I just don't remember what the sine of 30, cosine of 45, all those good things are. What I can do is I can imagine the pictures, so I can locate those triangles and figure out their reference angles, etc., etc. So for 30 degrees, obviously 30 degrees is in the first quadrant. So if you don't know that, we can draw it out. So sine of 30, let's see, so opposite 1, 2, root 3. So there's my special triangle for 30 degrees. Now for my red one for 45, this one's a little easier to remember. I mean, sine and cosine are both the same for 45, but that's okay. Here's my angle in the first quadrant. This would be 1, 1, root 2. And again, if we actually find the sine and cosine, 1 over root 2 would become square root of 2 over 2. So it's not necessarily a bad thing. And now we want to just go through and actually plug in the individual values here. So trying to simplify sine of 30 cosine 45 plus cosine 30 sine of 45. Sine of 30, opposite over hypotenuse. It's going to be 1/2. Cosine of 45 is going to be root 2 over 2. And again, you'll get used to some of these patterns with your answers here. We've got a plus sign. Cosine of 30 is going to be adjacent over hypotenuse, so root 3 over 2. And the sine of 45 is just root 2 over 2 again. So there we've got all our pieces. Now when we multiply this out, this thing is going to become root 2 over 4 plus root 6 over 4. And that's going to simplify to the square root of 2 plus the square root of 6, all divided by 4. And so that is equal to the sine of 75 degrees. Exactly. And again, exact means that we get radicals and fractions, not decimals. We don't like decimals. Decimals are bad. And so there we go. We now have the sine of 75, an angle that we couldn't have done anything with beforehand. Yeah. So, moving on. Okay, moving on to a second example. Now we want to find the cosine of some angle that can be expressed as either a sum or a difference. So in this case, we want to find the cosine of 45 minus 60. So again, we need to rely on one of our songs. This time I've put it up here for reference. I didn't think of that the first time, so sorry. And so that's going to be the first place I start. So I'm going to start with kind of getting the skeleton out using the song, getting the sine, S-I-G-N part right, and getting everything kind of set. Then I'll actually plug in the values by using these kinds of things. So first for the cosine, it's going to be the cosine conga. If I had a maraca thing, you can imagine I'd rattle it right there just to kind of get into the mood, but I don't, so that was kind of a moot point. But anyway, so we want to find the cosine of some angle minus another angle. So using the song, it's cosine, cosine, sine, 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 cosine, cosine, sine, 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 cosine, cosine, sine. So that means we have to switch to sine. It was minus, now we need to make it plus. Sine, sine. So there's our skeleton. There's the beginning. Now if we plug in the individual value angles here, we got 45 minus 60. So it'll be cosine of 45. So I can put in those pieces. So again, notice the angles go in order each time. That's nice. First one, second one, first one, second one. So we've got now another expression that means cosine of negative 15. We've got cosine of 45 times the cosine of 60 plus sine of 45 times the sine of 60. So to find this, we now once again need to draw out our picture. If you notice over here, we already had the 45, so I'll just start that one right here. redraw it just for simplicity. Again, I think people are pretty good with this one at this point. So again, cosine and sine are both going to be 1 over root 2, which is the same thing as root 2 over 2. For the second one, so if I draw it, so for 60 degrees, the difference here is that the opposite is root 3. So that makes this a 1, and that makes this a 2. So there's our 60 degree special right triangle. Again, we're trying to find non-special angles like -15 from special angles. And so now we just need to start plugging in here. So the cosine of 45 is root 2 over 2. The cosine of 60, looking at my picture, it's adjacent over hypotenuse. It's going to be 1/2. Then we need a plus sign, because that's what it changed to in the cosine conga. Then we need the sine of 45. Sine of 45 is just root 2 over 2. The sine of 60 is opposite over hypotenuse. That's root 3 over 2. And so there are all our individual pieces. Simplifying everything here, we're going to get root 2 over 4 plus root 6 over 4, which is a very familiar answer. Root 2 plus root 6 all over 4. So there's our answer. And again, what that equals is the cosine of -15 degrees. And yay, everyone's happy. Okay, so there's a second one. There's our example of cosine. Okay, to wrap this thing up, let's go ahead and jump in on tangent. So we want to find the tangent of 285, a distinctly not special angle, and we're going to find it by using one of our identities, this time the tangent sum identity. So we've got the tangent of some angle plus another angle, so that tells us we can use the tan, which that catchy beat makes you just want to kick up with your toe pointed. Tan A plus the tangent of B all over 1 minus tangent A tan B. I don't know what to say now. Tan A plus the tangent of B all over 1 minus tangent A tan B. And so then we've just got to start plugging into the formula. So first I'll do just like I did before. I'll use kind of the skeleton. So using the song, this is equal to tan A plus the tangent of B all over 1 minus tangent A tan B. So there's kind of my start. I've got all the tans ready. Now I've got to put the actual angles in there. So again, it doesn't really matter which way. So 225, 225. I guess it does matter which way, it just doesn't matter which color I picked first. I was kind of talking to myself there, just like I'm doing now. But all I'm doing is filling in the two angles, our two individual pieces, hoping that it's focusing okay here. And now once again, I'm just left trying to find these actual values. So I need to find the tangent of 225 and the tangent of 60. And what's nice though is in this formula we only have to find two separate values. We don't actually have to find cosine of 45, sine of 45, cosine 60, sine 60, or whatever angles are there. So to start off with, let's start with 225. It's going to be a slightly harder one. So 225 is down here. It's a 45-degree reference angle. So we can imagine there's our little 45. Look how cute it is. Well, you can't actually see it, so you're probably thinking I'm just talking to myself. So that means we got 1, 1, square root of 2. And so now if we're looking at ASTC to figure out whether this is positive or negative, tangent is positive down there. So that means the tangent of 225 is equal to positive, opposite over adjacent, 1 over 1, or 1. So it's a positive value. Wish this thing would focus more. Well, I'm trying. Okay, so for the green one, for 60, we've already kind of drawn this guy out a couple times, but we can do it again. Why not? That's why I'm here. So 60 degrees, that means we've got opposite root 3, we've got the 1 and the 2. The tangent of 60 is again going to be positive because A is everything's positive up there. Tangent of 60 is going to be root 3 over 1, or just root 3. And so there we go. Now we've got the tangent of 60. So here we go. We just need to actually plug in the individual values. So tangent of 225 is 1. Then we've got plus the tangent of 60, which is root 3, all over 1 minus tangent A tan B. So that's going to be 1 times square root of 3. And obviously the only place to simplify there is that 1 minus square root of 3. That's going to give me 1 plus the square root of 3 over 1 minus the square root of 3. So there we go. That is equal to the tangent of 285 degrees. And now we could obviously simplify this a little more. We could rationalize the denominator, but I don't feel like it. I feel like that's an acceptable final answer. It looks pretty nice, so I'm going to call that a day there. So once again, just to kind of review what we did, we went through some mnemonic device or some memory devices to help you remember these complicated formulas that were come up with by Jason Richmond, introduced to me by Jason Richmond and Jim Friedrich over at Laguna Creek High School. We went through some song and dance using a maybe familiar character, Megavolt from Darkwing Duck. So we used him to do the dancing as well as a makeshift disco ball. And then we actually did a couple examples here where we calculated out those values using the identities. So hopefully this has been helpful. It's a nice little addition, and you can laugh at me some more. So thanks.